everyone, I'm Miuccan D'Souza and welcome to my new YouTube channel, Miuccamatics. I'll be starting off with the course of Discrete Mathematics, under which I'll be doing the chapter Graph Theory. Let's begin. A graph consists of two sets, a non-empty set of vertices and a set of edges. A non-empty as we need vertices to create an edge. The non-empty set V, whose elements are called vertices or nodes or points. The set V of G is called the vertex set of G. The set E of edges such that each edge belongs to the set of edges associated with ordered or unordered pair of elements of V. The set E of G is called the edge set of E. The graph with vertex set V and edge set E is written as G of V, E or G corresponding to V, E. As you can see, the vertices are represented by dots and the edges by line segments. This is an example of an unordered pair, and here an ordered pair. Ordered pair as the direction involved is important. Finite graph. A graph G of V, E is said to be finite if it has finite number of vertices, else it is called infinite graph. If G is finite, mod of V of G denotes number of vertices in G, called the order of G, and mod of E of G denotes number of edges in G, called the size of G. A nice way to remember this is OS, as in iOS or Android operating system. A graph of order n and size m is denoted by n, m graph. Undirected and directed graphs. An undirected graph G consists of set V of vertices and E of edges, such that each edge is associated with an unordered pair of vertices. That is, U, V and V, U represent the same edge. A directed graph or a digraph G consists of set V of vertices and set E of edges, such that each edge is associated with an ordered pair of vertices. Each edge E equal to U, V is represented by an arrow or directed curve from the initial vertex U of E to the terminal vertex V. Here are some examples of graphs. This is a graph G with vertex set V and edge set E. The vertices are A, B, C, D and E. The edges are A, B, B, C, C, D and D, A. A note. In a graph, any pair of vertices that are connected by an edge are called adjacent vertices. A node that is not adjacent to any other node is called an isolated vertex. Note that node and vertex mean the same thing. In the above example, A and B are adjacent as they are connected by an edge, B and C are adjacent, and so on, that is C, D and D, A. Here E is an isolated vertex. This is because it is not adjacent to any other node. This is a graph G1 with vertex set V1 and edge set E1. The vertices are A, B, C, D and E. The edges are B, A, D, D, C and C, B. These are ordered pairs. Note that this is a directed graph, hence the order is important. B, A and A, B do not mean the same thing. As in the above example, vertex E is an isolated vertex. Some terms in a digraph. This is the given digraph. V4 is the initial vertex of E2. V4 is the initial vertex of E2 as the edge E2 originates from V4. V1 is the terminal vertex of E2 as the edge E2 ends at V1. E1 is incident with V3 and V4. This is because the two endpoints of edge E1 are V3 and V4. E1 is incident from V3. This is because the edge originates from V3. E1 is incident into V4. This is because the edge ends into V4. V3 and V4 are adjacent vertices. This is because they are connected by an edge E1. Here V1 and V3 are not adjacent vertices as there is no edge connecting the two. V4 is adjacent to V1. V4 is adjacent to V1, 2 because it ends at V1 or into V1. V1 is adjacent from V4. This is because the edge E2 originates from V4, or basically it goes from V4 to V1. So to V1 from V4. E1 and E2 are adjacent edges. This is because the two edges have a common vertex V4. A loop. A loop is an edge that is incident with the same vertex. Here, as you can see, the vertex V1 and the edge E1 connects vertex V1 to itself, same as in this example. E1 is a loop in these graphs.